Betelgeuse, a massive red supergiant star located in the constellation Orion, has been captivating humanity for centuries with its fiery red glow and its enormous size. For millennia, astronomers and stargazers have marveled at this celestial giant, which appears as one of the brightest stars in the night sky. But Betelgeuse is no ordinary star, it is a cosmic titan, a stellar behemoth that gives us a rare glimpse into the life and eventual death of stars far larger than our Sun. Astronomers have long estimated that if Betelgeuse were placed at the center of our solar system, it would extend far beyond the orbit of Mars, possibly even engulfing all the planets up to Jupiter. Imagine that, our familiar world, along with its neighboring planets, being swallowed by the enormous mass of a dying star. This astonishing size is just one part of the mystery surrounding Betelgeuse. As a red supergiant, Betelgeuse represents the final evolutionary stage for stars of its kind, and it is poised to end its life in a spectacular and violent explosion, a supernova. But the true question is, when will that happen? And what can we learn from this cosmic event? In recent years, Betelgeuse has thrown astronomers for a loop by exhibiting highly unusual behavior. In a stunning twist, its brightness increased by more than 50%, which suddenly propelled it from the 10th to the 7th brightest star in our sky. This dramatic surge in luminosity was completely unexpected, sending ripples of excitement and confusion throughout the astronomical community. A star's luminosity, the amount of light and energy it emits, depends on three key factors: its size, temperature, and distance from Earth. Betelgeuse, with a radius more than 700 times that of our Sun, is an absolutely colossal entity. But despite its size, the star's surface temperature is relatively cool, between 3000 and 3500 Kelvin. This coolness gives Betelgeuse its distinct red hue, marking it as a red supergiant. Even though Betelgeuse is massive, its cooler temperature makes it a prime candidate for a supernova, making the recent unusual behavior all the more fascinating. But the surprises didn't stop there. In late 2019, Betelgeuse became even more enigmatic. The star dramatically dimmed to just 40% of its usual brightness. This sudden and unexpected dimming was so striking that it was visible even to the naked eye, sparking widespread curiosity and intense debates among scientists. Was the dimming caused by a cloud of dust obstructing our view of the star? Or could it be a sign of deeper, internal processes at play? The possibility of an imminent supernova, Betelgeuse's grand finale, was suddenly back on the table. To investigate, astronomers turned to the cutting-edge capabilities of the Very Large Telescope, VLT, in Chile. The VLT captured high-resolution images of Betelgeuse during its dimming phase, revealing something extraordinary: the star appeared lopsided. This peculiar shape led to further analysis, which suggested that the dimming was likely due to a massive surface mass ejection, SME. In simple terms, this is an event where Betelgeuse expelled an enormous amount of material into space. It was a cosmic eruption of unprecedented proportions. The scale of the SME was mind-blowing. It ejected 400 billion tons of material, a staggering amount, far more than the typical solar flares or solar events that we observe from our Sun. This violent eruption not only altered Betelgeuse's appearance but also dramatically changed its pulsation cycle. Typically, Betelgeuse's pulsation rhythm took about 400 days to complete, but after this massive ejection, when a star like Betelgeuse exhausts its nuclear fuel, its core begins to collapse under the immense force of gravity. This collapse triggers a supernova, a brilliant and catastrophic explosion that releases enormous amounts of energy. The outer layers of the star are expelled into space, creating a dazzling, intense burst of light that can even be visible during the day. This would be one of the most extraordinary cosmic events in human history, and it could provide us with incredible new insights into the life cycle of massive stars. The first sign of a supernova would be the arrival of neutrinos, subatomic particles that travel faster than light and can escape the star's core. These neutrinos would reach Earth hours before the light from the explosion itself. When the light does finally arrive, Betelgeuse could shine so brightly that it might rival the full moon, casting eerie shadows on Earth and making the night sky appear as if it were day for several weeks. This unprecedented event would not only captivate stargazers but also offer scientists a once-in-a-lifetime opportunity to study stellar death in real time. By analyzing the light, heat, and radiation from the explosion, researchers could learn more about stellar evolution, the physics of nuclear fusion, and the creation of elements that are vital to life itself. To understand Betelgeuse's behavior, scientists have turned to sophisticated simulations, which allow them to model the star's interior. These simulations incorporate data from the most advanced telescopes, including the James Webb Space Telescope and the Very Large Telescope. By studying these virtual replicas, researchers can explore the processes that drive Betelgeuse's instability. These models have revealed that a massive bubble of gas likely rose from deep within the star, triggering the surface mass ejection and causing the changes in its pulsation rhythm. This is just one piece of the puzzle. The James Webb Space Telescope has also provided a closer look at the material ejected by Betelgeuse, uncovering intricate structures of gas and dust surrounding the star. These stunning images offer a glimpse into the complex and dynamic environment around a dying supergiant star. These observations suggest that Betelgeuse is in its final stages, offering an unprecedented opportunity to study the life cycle of massive stars. Astronomers estimate that Betelgeuse could go supernova in the next 10,000 to 100,000 years, but given the star's increasingly erratic behavior, the timeline could be much shorter than we expect. The astronomical community is on high alert, with scientists around the world racing to capture every piece of data before this cosmic drama reaches its dramatic climax. Every observation, every shift in behavior could be a clue that brings us closer to understanding when and how this star will meet its explosive end. In late 2023, the James Webb Space Telescope focused its unparalleled observational power on Betelgeuse, uncovering yet another startling phenomenon. Scientists discovered that, in addition to the massive surface mass ejection, the star had experienced a rapid internal collapse. This collapse was evidenced by significant shifts in the core dynamics of the star, which altered the flow of nuclear fusion reactions. Astronomers observed dramatic fluctuations in Betelgeuse's pulsation